Hello everyone, we've been working on the high-speed head for my Alexander Master Toolmaker milling machine. Now at the end of the last video we completely disassembled that head. Now before it goes back together again there's a couple of issues that need to be addressed, and the first one is with the main shaft of the head. Let me show you. Now, here we are looking at the main shaft for the high-speed head. The quill is at this end. The two journals here are where the lower bearings fit. And the collet, which is here, and that will hold the job at this end, the collet fits in that piece there. Now the drawbar, which is this other piece of metal, that fits in at this end of the shaft, and it has a internal thread just there, and that screws onto the collet and draws the collet in. Now, for it to draw the collet in, the collet mustn't spin, because if that starts to spin, then you can't get any pressure on it. So that's got to be held. And the way they do that is by having a pin in the shaft. And you see a little round circle there. Now that is the end of the pin that's been riveted over. And that pin engages into the keyway just here on the collet. Now, I've got a problem here that the key doesn't exist on the inside. That pin must have been damaged at one time and someone's got a chisel or something down there and knocked it off. So, although we have this end of the pin, which has been riveted over, there's no pin on the inside. What that means is in the future, when I go to tighten up the collet using the drawbar, if for some reason this starts to spin, then I can't stop it because there's nowhere to hold it. All you see is that face coming out. Of this end, and that's where your cutter's going to be. So I've got a bit of a problem. I need to change that pin and put one in that's full length and will engage into the collet. So the first thing we need to do is remove what remains of the pin that's still present in the shaft. There's the top. We also need to find out its diameter, so we can't drill the whole thing out. I place a centre dot in the head of the pin and then start to drill. The hole looks off centre, and it is to the pin's head, but I'm hoping that it's in line with the centre of the shaft of the pin. The hole is getting deeper now. I'm taking it easy as I want the head of the pin to fall off. Just like that, it's gone, and now you can see the drill was in line with the shaft of the pin. Phew! As can be seen by the sexy angle of the pin shaft, this punch has seen some action. The shaft of the punch, just here, is 1.5mm in diameter. That fits nicely inside the 2mm hole we've just drilled in the shaft of the pin. This image is looking down inside the main shaft. You can just see the broken end of the old pin. Just there. I tap the punch with the hammer. The pin's a little tight, but it starts to move. You can see it quite easily now. It comes out with no trouble. Here you see the punch sitting in the 2mm hole in the end of the pin. That old pin measures 2.34mm in diameter. I have a length of silver steel rod that measures 2.37mm in diameter. We can make our new pin out of this. With a silver steel rod in the pedestal drill, I use a piece of 400 grit emery paper and a drop of oil. The diameter soon comes down to 2.34mm. We have the beginning of our pin. It's now the correct diameter. The next thing to work out is how long does it need to be? Now that's a good question. I sketched the collet. The depth of the keyway is 1.64mm. The wall of the shaft the pin will need to reside in is 6.78mm. So if we say we want the pin to protrude, say, 1.2mm inside the shaft and the head of the pin to be sub-flush by, say, round about 0.3mm, then we can work out the length of the pin. Our pin needs to be 7.68mm in length. I cut off a piece of rod. It happens to be 9.3mm long, a little more than what we need. I clamp our material in the soft jaws of the vise. Then, using a small ball peen hammer, I mushroom one end of the pin. I turn the pin upside down and clamp it again in the vise. The mushroom head will sink into the soft jaws, so it won't get damaged. I file this end until the pin is at the correct length. That's 7.68mm long. And here is the finished pin. I've just taken the sharp edges off of this end and filed a short taper. This should ensure that it will engage with the top of the hole in the shaft and then allow the pin to be tapped in nicely with the hammer. And this is that hole in the shaft that our pin needs to fit into. Just like that. And now we should be able to knock the pin into the shaft. And the pin is looking pretty good. On the inside it seems to be sticking out round about 1.4mm. I can't measure it very easily because it's right down the hole there. But if we now move this down a little, get the collet. Now the pin needs to go into this slot here, this keyway just there. Now if I put it in with the keyway obviously away from the pin, it will go in and it bumps against the pin there. If I turn it round so it lines up with the pin, which is about there, and in it goes. So it doesn't turn, I can pull it out, so it's not too long and binding against the bottom of the keyway, which is good. I think we call that a success. Woohoo! You will remember the nut that I had to remove with the hammer and chisel that held the pulley block in place. Well, yesterday I received a phone call from the metal stockist, and they have received the piece of metal that I ordered. This is a piece of EN1A steel, and this is what we're going to be using for making the new nut out of. So it looks like we have some machining coming up. I place the steel in the chuck of the lathe and then drill a centre hole in one end. I face that end to make sure that the surface is flat and square to the sides of the bar. I remove the facing tool and replace it with the parting off tool. I line up this side of that tool to the end of the bar using a steel rule. With that set, I move the parting off tool 11mm towards the chuck and bring in the tailstock with a revolving centre. The centre will support the bar as we make the cut. One last check with the steel rule and start to part off the first blank. It takes a couple of minutes as the tool is a way to go. Once the tool is cut through, I pull the centre away and remove our first blank from the lathe. This is the blank we've just parted off. You can see here this is the nice shiny side we started with, and this is the side that's been left by the parting tool. Now I need to get this side nice and flat, so I want to turn this side, but of course the blank isn't very deep and the chuck is deep. So what I'm going to do is put in a parallel like this. So this is now against the flat surface of the chuck. I can now push the job in there against there, and that will make this side fairly flat with that side. But I need to push in whilst I'm doing the jaws up. And the way I'm going to do that is with this adapter. Now this is a 3:2 Morse taper adapter. It's a 3, so it will go into the tailstock. Nice thing about this adapter is it has a hole just here, so that hole will go around the pip that's left in the centre of our blank, so I can just push against the job like that. I now know that that's being pushed nice and evenly around here. If I tighten the chuck like that, our job should now be nice and square in the chuck. All we've got to do now is turn it on and let's have a look. And that's looking good. The job is nice and level. I can't see it waving around a bit, so now we can go ahead and turn down this face. We're in a little closer now. The facing tool is in the tool post and we can clean up this second surface. Now the blank needs to be around about 10mm thick. It doesn't have to be exact. And what we have at the moment is 10.9. So we've got a millimetre to come off of the thickness of this blank. I do 2 passes across the surface. Now let's measure how thick our blank is. Now then, that should be round about 10mm now. Let us have a look. We've got 10.04. That will do nicely. Our blank is now in the indexing head, and I've put the indexing head on the table of the milling machine. Now the next thing that we're going to need to do is drill 2 holes in the top of this blank. Those holes are the place where the 2 pins from the pin wrench will fit, so we can do the nut up and also undo it again. So let's come in a little bit closer and you can see what I'm doing here. Now, I've fitted a small centre in the collet of the milling machine. I've brought the head forward so it's almost over the centre that's drilled into our blank here. Now, the indexing head is loose on the table of the milling machine. So as I bring this centre down, it's going to move the indexing head to there. And now that indexing head, the centre of the indexing head is in line with the centre that's in the collet. So if I now tighten the 2 clamps up that I've put on here, the centre is now directly over the centre of the indexing head. I've removed the centre from the collet of the milling machine and replaced it with this device, which is called a wobbler. Now what a wobbler is going to do is detect the edge of our job. Now the way it does that is I'll turn the machine on, the wobbler will rotate. Now the head of the wobbler is a cylinder that's 5mm in diameter. Now you move the job towards the wobbler, and as the cylinder starts to rub against the edge of the job, when it becomes parallel, the wobbler will kick sideways. At that point we know that the centre of rotation of the wobbler is exactly half the diameter of the end of the wobbler. So we would be 2.5mm away from the edge of the job. And as we all know, 2.5mm, that's 98.5 thou. So when this kicks sideways, with 98.5 thou away, we then stop the machine, push this out the way, we then move the job on the x-axis in this direction, 98.5 thou, and we find that the centre of rotation is directly over the edge of our job. We can then progress it another 4mm in, which is the distance to our first hole, and then we can drill our first hole. I turn the motor on and move the job in that direction. The wobbler has started to touch the edge of the job now. We keep going, but slowly, waiting for the head of the wobbler to kick sideways, like that. We now know the centre of rotation of the vertical head is exactly 2.5mm away from this edge. That's 98.5 thou in imperial. So all I need to do is move the bed of the mill in that direction, 98.5 thou. The centre of rotation of the head will now be exactly over the edge of our job. I've removed the centre from the milling machine chuck. I've replaced that with an ER20 collet chuck, and in that ER20 collet chuck is a centre drill. Now I've also moved the job and the table in this direction, 98.5 thou, so the centre of this centre drill and the vertical head is directly over the edge of our job. Our hole needs to be 4mm in from this edge, that's 157 thou, so I'm going to move the table in that direction, 157 thou, using the wheel just here. So that is 157 thou just there. The centre drill's left a nice pilot hole. The next thing we want to do is drill another pilot hole on the other side of the nut, 180 degrees around. So I'm going to rotate the indexing head 180 degrees. To rotate the indexing head, we rotate this wheel here. There's a gear ratio in here of 90:1. So if I want to revolve this half a turn, 180 degrees, I need to turn the wheel 45 times. Oh, take off the lock first. And 45 is just there. 45, put the lock back on. We're now 180 degrees out from our first hole. The way the milling machine is set up at the moment, I can't get the drill in to drill the correct depth of hole. So what I'm going to do is drill the hole on the pedestal drill just here. Now I've set the depth stop, so the drill will stop just there, which is 7mm under this level. So this will drill a hole 7mm deep, and we'll use the hole we drilled with the centre drill as our pilot. We just need to chamfer the hole now, which will allow the pin from the pin wrench to fall in there quite nicely. So we take off this sharp edge. And now we can check to see if our pin wrench goes into the hole. There are our two 3mm pins, and they fit nicely in. We have our nut blank back in the lathe. I want to remove some material from its centre, and this will make it easier to turn out to the correct size and then cut the thread in a little later on. First I drill a 4.5mm diameter hole. Second, a 20mm diameter hole. The third drill is 25mm in diameter. Then I take the blank out of the chuck. And this is that blank. And this is its brother. I have two blanks just in case we mess the first one up when we start to cut the thread. Now, cutting the thread is the next job to do. We need to put a 16 TPI thread in both of these, a left-hand thread that is. Now, unfortunately, my lathe can't cut a 16 TPI thread at the moment because it's missing a couple of the thread cutting gears. However, I have a friend who says that his lathe can cut a 16 TPI thread, but we've got to go over to his workshop to do that, and he's busy for the next couple of weeks. So that's a bit of a shame. So with that, we've got to wait for him to come online so we can use his facilities. So with that, could you do something like this? Of course you can. And with that, this video is at an end. Take care, everybody. I'll see you next time.